let's give it a start. The clock hit 30. So with that, the stage is yours.
Okay, thank you very much. And also from my side, welcome to this talk, Challenge and Solutions for Jetting in Printed Electronics. My name is Irving Rodriguez. And before we start with the presentation, I will give a few words regarding the company where I come from. So the whole work was made at the company Essemtec in Switzerland, and we belong to a bigger conglomerate called Nano Dimension. And Nano Dimension is a leader in additive manufacturing with several companies under his umbrella, like Fabrica Group, Admatec, GIS, Deepcube, etc. And this is our company, Essemtec. So we are a provider for solutions in the SMT industry. And as you can see here, we provide all type of solutions like high-speed dispensing, printed electronics, which is the topic for today, complex volume repair, etc. And now this is the agenda. So we have several topics, for example, rheology and its consequences on jetting. This is our expertise. Dot design and library on our software. I want to show you also our unique solution, reference in printed electronics. And at the end, we're going to have like a takeaways. Okay. So rheology and its consequences. So pretty sure all the people who are working on jetting, they know this chart. So let me use my pointer. Here you see what happens when you shear a material with particles. So you apply shear tightening, and then you see a lower, dramatically decrease in viscosity. And you see at the beginning, you have a high viscosity when the material is at rest. And once you start ejecting your material, you are start to putting your material onto your substrate, the viscosity gets reduced dramatically. So you will see almost, it's typically at least, I would say, a factor of 1,000. And also on this chart, you can see the difference on temperature, the effect of the temperature, solder paste 30 and 40 degrees, and the structural glue 30 and 40 degrees. That's also significant, I would say. But the main decrease in viscosity you will see to shear tightening due to the shear rate. And this change happened already in your chamber, whatever the jetting technology you are using. This effect is happening within the chamber of your jetting system. The second chart is also very important. You will see here at the beginning, you have fluid without particles. So in this case, we have water. And here we have a pure Newtonian behavior, which that means it doesn't matter which shear rate you apply, you will not see a shear tightening effect. But once you start increasing the particle concentration, let's say 9%, 18%, 28, 24%, you start seeing, for example, that's 43% the shear tightening effect. That means you start moving your material within the chamber, and then the viscosity can decrease. And also, let's go to the chart, to the line of with 50% particle concentration. You see this shear tightening effect. And at the end, something very special. So when your material is no more in flow, that means the shear rate is so high that you have like a chaotic behavior of your particles. And then you start producing like a shear thickening. So instead of reducing your viscosity, you start to increase in your viscosity. So this is a typical effect when you have a very high shear rate. It also depends on your particle form. But I show these two charts because it's very important to consider once you choose which medium are you going to use and which system you are going to use to make your jetting, right? And of course, we have the expertise at the Essemtec to overcome this challenge. Now the dot design. Here I have two different situations. This part here is a component, SMD component. Here you have conductive, adhesive, or solder paste. And in the middle is the a structural glue